So in example 3, we're asked to order the real numbers that are given from least to greatest in each set. With part A, we're given 2 times the square root of 10, square root of 20, 6.25, and 4.5. We need to write them in some type of similar format in order to be able to compare them effectively. So first we'll look at 2 times the square root of 10. If you get out your calculator and check that, it is approximately 6.325. And you could get that through successive approximations as well. Get it close enough that you can compare, but it is much simpler if it is allowed to use your calculator. With the square root of 20, that's the same thing as the square root of 4 times 5, which equals 2 times the square root of 5. And we could remember that that's approximately 2 times 2.236, or again, you could put it in your calculator and get that this is approximately 4.472, and then 4 1/2 equals 4.5. So if we put those in order, and we have 6.25 here as well, if we put those in order, we've got that this is going to be first, the 4.472. The 4.5 is going to be second. 6.25 is going to be third, and then 6.325 is going to be fourth. And if we put those in their original form, we get square root of 20, 4 1/2, 6.25, and 2 times the square root of 10. Similarly with part B, the difference is that the more negative a number is, the less it is. So in this case, the absolute value being bigger is going to mean that the number is actually smaller. We're still going to do those approximation. Negative square root of 5 is approximately negative 2.236. Negative 2 1/4 is negative 2.25. Negative 2.23 is already written in the form we need. And then negative 9/5, that is the same as negative 1.8. So in order of least to greatest, we're looking at negative 2.25 being first, negative 2.236 being second, negative 2.23 being third, and then negative 1.8 being fourth. Putting them in their original form, we have negative 2 1/4, negative square root of 5, negative 2.23, and negative 9/5.